Oye and Yolota. So, this is a video that we're putting together in preparation for Season 12, Practice Round 1. So I'm going to go over to the internet. We have our practice round competition preparation prep zone. So we've got all sorts of information. Reminder, STK 13.0.0 Premium is required for this season. As a quick heads up, that's the icon right here where we've got STK 13. Has kind of the yellow outline, maybe an orangish, but we've got the black background. When you're opening these up, I've fallen prey to this a couple of times. The ODTK 13 is not what we are using, but it is also installed along with STK, so just as a heads up. They have very similar icons. ODTK will tell you you don't have a license unless maybe you do have a fancy license. You can see I still have STK12 on here. I probably will remove that here in the near future, but that's from previous seasons. We're looking for this one. I've also loaded up a scenario that I've been working on for actually a little while. This is an alpha version of it, but I've been turning it over in my head for a while. We'll talk about some of the details on it, but I've put together some of it inspired by our prep list, and that's what I wanted to make this video about. But I wanted to stop first and say make certain that you have STK 13.0 installed and fully licensed. You will need that for this competition round and for this season. So make certain that you have access to that. Failing that, let's see, training materials. If you go to the StellarXplorers website is the easiest way to find my website. I even find my own website that way. So going to ISAT, we have linked on the front page with, well, not exactly on the front page, but we've got wide beam transmission, the announcements. And then the first one listed is 10 September, a playlist that is now available that shows you how to create your license files, submit those over to the fine people at StellarXplorers to try and get everything up and running. So take a look at those if you have not already. You will need STK up and running in order to do practice round 1 and qualifier round 1, if not more. We will definitely need them more later in the season. Okay, jumping into the details on that, we've got, let's see, the practice round is available during these windows, which is coming up here in the near future. As of the filming of this video, this is 6 October, so this is just before PR1 is starting to open up. We've got it in just a couple of days, so hopefully you get this video in time. Hints to help your team prepare for PR1. That's what I wanted us to take a look at with this video. I know for teams that have mentors that are very familiar with the competition, like myself, they would have easy access to a mentor being able to give information to competitors on it. So, in trying to support fairness across the board, I figured I'd go through and share some of my immediate thoughts on what we're doing with these with these hints here. Now, I've done a few of these in the past. Sometimes I have a clear idea on what's going to be expected, and sometimes I'm way off on the mark. So, take everything that I put out here with a grain of salt. One thing that I will note is, because this is a practice round, team directors and mentors may help students with the scenario. I'm going to do a small plug here as someone who has been a mentor for quite some time and has from time to time taken over the duties of team directors. Especially if you have a new team, team directors and mentors, it definitely it's good to help out to make certain that the students can get an idea of what they're doing in this competition and help them overcome any stumbling blocks. Though I would emphasize out there for everyone who's in a position like me, a technical mentor, make certain that you're letting the students set their own pace, and I like to only try and give help not proactively, but only answer questions that students will actually bring to me. Though, if it looks like they are getting stuck on something, or in general, so in the practice rounds, I should say only, that's where you can actually do a little bit of helping out. If it does look like they're going down a very wrong interpretation or something like that, in the practice round, it would be okay to give them a little bit of a nudge to get them back on track. Remember, we have very few competition rounds. The practice rounds, the score is non-binding, so they usually allow for team directors and mentors to help during the practice rounds, never during the qualifier rounds. But we want to make certain that the students are actually getting a good idea of what they would need to do during the qualifier round. So make certain, as best you can, that the students are setting the pace. Okay, now that we've talked about that, let's jump into our list. Know how to calculate access times. Now, I've got a lot of this over on the ISAT website. We've got, let's see, general knowledge, basic STK functions. In fact, a lot of what we want is in here. So we've got adjusting orbits, access times. You're welcome to take a look at that. But as a brief review, if I come into this scenario that I've been setting up, which is all about putting a satellite in orbit equipped with my approximation of a LiDAR sensor to actually scan the jungles of Central America for lost cities and temples of the Maya civilization. And I've gone to a couple of them myself, including Tikal and Chinantanich, and they were absolutely incredible experiences. And from what we've learned, there are a lot of other sites that were likely swallowed up by the jungle. So, while usually the LiDAR is being used by light aircraft, is my understanding, or drones, this is another possibility of something that we could take a look at. And with one of the other suggestions, I think a good one for us to look at here. Okay, the brief idea is I have a satellite with a little sensor. Now, LiDAR is usually something that's more directly pointed downward, so I have a decent sized cone angle on this. We might have larger or smaller if you look at some of my other scenarios. This is likely to be one when it gets to its final form that the actual cone of the sensor will be even smaller than what we have here. I've set it up to be a 5-degree half cone angle, and that would represent a little bit more about the limitations on how a LiDAR system works. Many times it's actually a very small beam that would then go down. Without going into details, this is my satellite and I want it to try and scan the jungles of Guatemala. Now I've chosen Guatemala because it has an interesting shape and is site for quite a few Maya cultural sites. Like I mentioned before, we went to Tikal, actually, which was a major center for the Maya civilization, and it's absolutely fantastic. Belize is another one, and then along the Yucatan in here are places where the Maya civilization flourished. Now, it also extended even further than this, but for the purposes of this, we're going to take a look at Guatemala. The other thing that I've introduced is at UT Austin, I believe, there's a Center for Mesoamerican Studies where it seemed to be a little more artistically focused, but that would be a place where I expect that there would be researchers that would be interested in finding out more about the Maya civilization, among others. So what I've set up here is we have a ground station in Texas. We have a target area specifically in Guatemala, and we've got a satellite with a sensor with a limited cone angle on this. So one of the things that we're likely needing to do for my scenario here, we're going to be looking at an area that we're trying to scan, but we want to try and get that information back to a ground site, say UT Austin. So in this case, what I would want is I would want communication between the satellite and UT Austin. So go into this. There are a couple ways that we can bring up the access time. My favorite way is to go to the satellite itself, right-click on that, and go down to Access, not Deck Access, but just regular access. Click on that, and then it says, okay, for my satellite, what do you want it to talk to? Now, I could select the area of Guatemala, but that could get a little bit interesting. What I really want in this case is talking with UT Austin, so it could send its data back over there. I'm going to select UT Austin. So in doing so, I've got my object here, the satellite, ISAT, trying to talk to my target, UT Austin. So I'm going to click Compute, and then I'm going to bring up, when I did that, you may have seen in the background, my 2D map actually filled in some contact areas. I can go over to the reports right down here where it says access, and I'm going to click that button, and it brings up my access report. Please note it says satellite ISAT to facility UT Austin. Make certain that you're pulling the right access report. By default, I haven't changed much of the settings in this. This is still just a brief setup for this particular video, but I am going to try and work on this scenario in the near future to be another practice one for students to use with the ISAT website. My duration right now is in seconds. I can right-click on this and go over to report units, and I could change that to minutes. I could also set that as the default so that it always comes up as that in the future. I'll go ahead and do that. So now I can see in minutes or in hours or in seconds. It all depends on what you're trying to use. But this is our access report. It shows us our start and stop times, the duration of an individual contact, and we've got at the bottom our minimum, maximum, and mean values. We've also got our total minutes. Depending on what you're looking for your scenario, this is a very, very important report. And it's easily accessed, like I said, by right-clicking on one of your objects, going to Access, and then selecting the others. I could have also gone through with UT Austin, right-clicked on it, selected Access, and then selected the satellite, click Compute, which is already there, and then pulled up the same report. Notice how it's now in minutes because that's what I set as the default. Now, another thing to keep track of, a few of my scenarios, especially with the C series and beyond, we add a lot of sensors. Maybe I want to see the contact between my LiDAR sensor and UT Austin. I'm going to compute that and bring it up, and there's no access found. My orbit is not well designed to actually have the LiDAR make contact with UT Austin. It may not even be a good orbit for me to contact UT Austin with my satellite. But that being said, here's how we can access the access times. Another way that you can do that is we could go to the satellite. We can go up to, I believe, Analysis, Access, and it brings up the same thing. I like doing the right click myself, but depending on what type of computer you're on, maybe you're not using a mouse or maybe you're not as comfortable with it. So those are some options. Once again, Analysis, Access, not deck access, but access, and then now you can select your targets. If I wanted to do Guatemala and ISAT, I could do that, compute, bring up my access report. Here we go. And then I get my access report between the satellite and the target area of Guatemala. Okay, so that's our access times. Going back over. So that's item 1. Item 2, know how to find the range, distance between two objects. There are a couple ways to go about this, but the main one that I think they want us to take a look at is if I wanted to find how far ISAT was, my satellite, from my target, or one of my targets, I should say, UT Austin, we go back over to that access report menu. So I'm going to right-click, go to Access, and I can do the following. If I wanted to find the contact info between UT Austin, instead, I'm going to expand this. Normally we go to Reports and Access, but underneath it we have AER. This is actually one of the fastest ways to bring up your range information. So I'm going to click on that. AER is azimuth, elevation, and range, if I am not mistaken. A, azimuth, elevation, E, and R, range. So in this, azimuth and elevation, keep track of basically azimuth is looking at how much east to west you're looking, is a simplistic way of imagining that. Elevation deals with how much you're looking up or down. And so this is keeping track of three-dimensional motion in two-dimensional space. If you're familiar with it, this is actually a manifestation of what's normally called a spherical coordinate system. Now, unless you have limitations on line of sight in an interesting way, most of our StellarXplorers programs are probably not going to have you do too much with azimuth and elevation. It's the last column that we're most interested in, range. So I can see on 7 October, which is just part of the scenario, I didn't bother changing the days too much, I have a range of about 3,700 kilometers and then ending at 3,700 kilometers. Most of mine are actually do that. I have a closer approach over here where I get down to about 2,900 kilometers, but we can start scrolling through, and this is a 2-week scenario, so this is a pretty long list. But you can go through and you can see the ranges involved on this. Now, this will only populate information that contact can actually be made, so you might have to get a little bit creative on this. Now, my satellite doesn't have any specific limitations, at least that I recall putting in there. But if I were to do this with my LiDAR, I might not be able to get as much information. So be thinking about what objects you're trying to find the range between. Please note I have ISAT to the facility at UT Austin. So that is what I'm getting the range for. Now, if I were looking for instead the range to Guatemala, that would probably be different. Although Guatemala in this case is not a single location, it's actually the entire country of Guatemala. So I don't know exactly what that report would look like. And to keep this video moving, I'm not going to bring that up. So That being said, we've now shown you how you can find the range distance between two objects. Next up, know how to calculate the percentage of a region covered. Now, this is something that we haven't seen, at least from my recollection, for quite a while, actually. And it was one of the things that prompted me to want to set up to make this video. Like I said, I've already got things for access time and to some extent for range, I believe, as well, reports and graph manager, but area coverage is not something that we see all the time. I do have some videos on it. In fact, I went back and watched some of them under Pro Functions STK. Now, this organization is actually from a much earlier version of STK many years ago, where you had the free version and the Pro version, and lighting times and area coverage were part of the Pro version. So that's why I have them over here. It's not quite that way anymore, but it seemed like a decent way to actually sort them. I've got lighting times and area coverage. And I brushed back up watching my own video on area coverage, and hopefully I've got everything set up so that I can walk you through the ideas of checking the area coverage, because we were told to try and get you set up to do that. Know how to calculate the percentage of a region covered. Now, here's where things are going to get a little bit tricky on that. The reason I say that is in order for us to actually have that, we kind of need an area already designated, which I do, Guatemala. I just went with the country of Guatemala instead of my original plan of Guatemala, Belize, and then also parts of the Yucatan Peninsula so that I could save a little bit of time. It turns out many of the countries are actually preloaded into STK, so I just brought up Guatemala because there are quite a few sites in Guatemala. That being said, I have added myself, well, using stuff built into STK, so credit where credit's due to the fine people at AGI, they have Guatemala actually already set up inside the scenario. My bet is StellarXplorers is going to send you in your scenario already set up an area, and you'll want to use it and not make any changes to it. Then I also added Guatemala area coverage, which is a slightly different item in there. My bet is what you get from StellarXplorers is going to have your area, or areas, and it will have a coverage area, which is a different object built into STK. I wouldn't mess with any of the settings on those. In fact, they argue, or they say you shouldn't mess with any of the settings on most things other than changing your satellite's orbital parameters, which we're actually going to do in part of this. Okay, so I've got this set up. In fact, let's take a look at the ISAT satellite real quick. I've got it set up in an apogee and perigee altitude of 1,000 kilometers, so I have a circular orbit, and I've currently got it set for an orbital inclination of 14 degrees. Now, the reason that I've done that is I've got it where the satellite is going to basically scratch the bottom of the country of Guatemala. So I'm going to get a non-zero signal, but not a great signal, which is exactly what I want. Now, I'm pretty certain this is what you're going to do to actually bring up the percentage coverage, although in the past it's been common in scenarios that require you to do that for StellarXplorers to include a set of instructions in the appendix or appendices where it'll walk you through and tell you how to do it, but just in case, I'm going to show you what I know to do. Now, I may be doing this slightly wrong. It's been a while since we've done this, but I am getting what I'm pretty certain is the correct values on that. In order to get this, we have our actual target area of Guatemala, and the icon for that is like a little planet Earth with a yellow target symbol on it, like circles, concentric circles. What we want, however, is the other related target or item to it, which looks like a planet but has like a little satellite there and then a scanner beam coming down on it. And so what we want to do is go over to Guatemala coverage area. I'm going to right click and go down to coverage definition. I'm going to compute axes, and then I'm going to go back over there and go to, so coverage definition, and go to grid inspector. Now, I've mentioned this in one of my videos. When you bring up the grid inspector, it's kind of hard to zoom in. So maybe you want to, on the 2D map, zoom in some so that you can clearly see where your target area is, because you're going to need that. So I'm going to right click on my target area coverage, coverage definition, grid inspector, and now, from what I recall, we need to switch over from action, or action select point, we want select region. Then you go over to your 2D map, not the 3D, the 2D. and click inside your area that you're wanting to look at, which for my case is Guatemala. So I'm going to click there. We can actually see that it's outlined Guatemala, and on this it has filled in some information about it. Percentage of region right here, 33.56%. So with my current orbit, and the way that I've set this up, it's actually giving me area coverage from my LiDAR sensor. Again, I'm pretty certain StellarXplorers will set that up for you, so I'm not going to go into the details of that. I wouldn't bother changing those unless you have been directly instructed to do that. This says 33.5% coverage, percent of region covered. So that's exactly what we're looking for. Often you want to go in and try and get good area coverage, covering most of the area. Now, my problem is I'm too far south. In fact, I'm going to emphasize that by taking my orbital inclination down to only 13 degrees. So I'm going to send my satellite effectively even further south. Now, when I do that, let's see if it updates automatically. I'm going to right-click on the coverage area, go to Coverage Definition, Grid Inspector, Actions, select Region, and on my 2D map, click on Guatemala. And we can see here, I now have 0% of my region covered because my satellite now isn't going high enough north because of my inclination. I'm not scanning Guatemala with my LiDAR sensor at all. Okay, well, I went the wrong way. I want to actually send my satellite back further north. So I'm going to bring it up to 15 degrees orbital inclination, and that should get me to cut across Guatemala a little bit more. Let's go over, right-click, Guatemala coverage, go down to Grid Inspector, switch it out to Select Region, and I'm going to click on my 2D map. I'm now up to 67% area coverage. Well, that's good to know. I'm going to go over and try and bump that up a little bit more. Let's go up to, 17 degrees. I'm going to jump up a little bit more, and let's see what I've got now in my coverage. So I'm going to right-click, go down to Coverage, Grid Inspector, select Region, and I'm going to click on Guatemala. I have 100% coverage. Okay, now I'm scanning everything. I'll give you a hint. Sometimes with these, it's not in your best interest to cover 100% of the area, because a lot of times to cover 100% of the area, you're going to start losing out on some of your contact times. But that's going to depend on the actual scenario. Here's how I know, or at least the method I'm familiar with, to actually calculate up the percentage of region covered, which is one of the items on the prep. This is also something we haven't seen in a couple of years, so I figured I'd go through and actually show you that. To set these things up is a little bit more complex. Like I said, I had to go back and watch my own video for the other one. You're welcome to check out the other video if you're really interested, but I'm willing to bet they're going to send out the VDF with all the information you need. And most likely, the only thing that you should change are the orbital elements that you're allowed to for your satellite. We'll talk more about that in just a moment with our penalties. But that is how you find the area coverage. A few things on that. To my knowledge, the way that that interface works, you can't do my favorite trick of leaving that window open and just hitting refresh or anything. You kind of, my understanding is, maybe they added it in STK 13.0, but I don't know of it yet. You kind of have to actually do the right click, go to coverage definition, go to grid inspector, click over to select region, and click on your region every time. So that can be something that might get a little tedious. Years ago, when we actually did around with this, at one point, the system kind of broke and it kept giving us the same percentage the entire time. If you think it's giving you weird results, my favorite thing is to go back into your satellite, bump it down to, say, 10 degrees, for instance, and we can see that now I'm nowhere near scanning Guatemala. Go back in, right-click, go over to your coverage, double-check what it's giving you. Put it in a spot where you know it should be 0, and if it gives you a number that isn't 0, you should probably close out the scenario and reload it from the original file. In fact, I'll talk about that here in just a minute, but I want to keep going down the list in our prep. Okay, so that is the percentage of the region covered. Understand the relationship between a satellite's position and UTCG. Now, UTCG is, we found out from StellarXplorers that AGI refers to UTC, which is Universal Time Code, as UTCG. It's probably global, that's a standard notation for it, but it's actually keeping track of the different time periods and time codes on Earth. Give me just a moment. I have a whiny cat who needs out of this room. Yeah, I hear you. Yes, I'm getting the door. All right, very sorry about that. I knew I should have let her out first. Okay, and we're back. So, what we ended up needing in the other scenario was basically this. So, universal time codes are based off of, there are a couple different ways to refer to it. In the military, it's usually called Zulu time. It's also called universal times, hence universal time code. And it's also called Greenwich Mean Time. And it basically sets that at the prime meridian, which cuts through Greenwich, England, hence Greenwich Mean Time, and through part of Europe, basically right along here, pretty close to the terminator, which is the technical term for where the light and the dark meet on the planet here. Now, that's just completely random with how I've set this up, but we would have it where UTC, so Zulu time, is based off of Greenwich Mean Time here. Time zones are basically adding or removing hours from the Greenwich Mean Time, the universal time code. My understanding is with regular space missions and military time, everything's kind of based globally around UTC, Universal Time, Zulu Time. So basically, midnight is when the darkness is completely centered around Greenwich, for want of a better term. One of the things that we ended up seeing, so I went through a whole thing in one of the previous prep videos when we were told about this particular item, have students be familiar with UTCG and a satellite's position. And I started talking about the GPS system, which is still actually applicable, and the universal time codes are used for that in a way to actually get our global positioning satellite system up and running. But what we ended up seeing in the last one was the idea of setting up for actual, for want of a better term, time in space. So when I'm looking at the Earth right now, I'm looking such that the sun is directly behind me. How do I know? Well, because I'm looking on the bright side of the planet, which means right down the middle of this, maybe right through Panama, is probably right around solar noon, about midday. So in that time zone, it would be about noon at this time. I can press play, and the Earth spins underneath, and now Panama may be moving to 1 p.m. or 2 p.m. And then we've got Guatemala here that went through noon. There went Austin, and now we've got it where noon is probably cutting through maybe the Pacific coast. So we've got, say, California going through the middle here. Now we've got high noon going over parts of the Pacific Ocean. We're coming up on Hawaii. That's probably a little bit to the left there, so that might be 11 o'clock. Then we're getting up to 12 o'clock, that sort of thing. So this is the other thing that came up last time when it was the satellite's position and our relationship to UTC. So the local time. We ended up having a very polar orbit, but we ended up having a time-based target. So panning around, we can see the sun in the background there. I'm going to block the sun with the Earth. Now I'm on the night side, and we can see that probably right through the middle here is about midnight. So we might have targets that we're wanting to see at, say, midnight. Well, then you have an idea that this is the side of the planet you want to be looking at. It's going to be the dark side. Or maybe we can only access it during the daytime, maybe around noon. So that would be back over here. So I don't want to go too much more into it, but that's what we needed, or the key info last time we had the line item of understand the relationship between the satellite's position and UTCG. So it's basically relating to the time zones, and if you had a specific time that you wanted to target a location, you could try and set it up where your orbit is favoring that location. Okay. I want to keep all this moving, so let's keep going. Understand the relationship between period of an orbit and its apogee and perigee. Now, this one I did a lengthy video on. Let's see where we've got it. General knowledge. I believe it is orbital periods and resonance. I'm still working on all the videos related to that, as you can see. But with this, we've got orbital periods lesson. This is a longer video. I'm going to direct you all to take a look at that, but I'm going to give you a brief summary of it. Kepler's third law of planetary motion. So when I go back to home and I scroll down, we have Kepler's laws of planetary motion. We've got them with both rundowns of how they manifest in STK, and we've also got lessons that I put together for my AP Physics classes on what they actually mean and what they say. Kepler's third law basically says the further out the orbit is, the longer the period will be, the longer it takes for one complete orbit. And so we can slow down our satellite by actually taking it farther out, and your semi-major axis, which I go into detail in that first video on orbital resonances and orbital periods, I talk about the mathematics behind it, but if you raise your apogee and raise your perigee, you can actually then increase your period, or you could decrease your period. So one of the other things you can do is when you go into the satellite and bring up its orbital parameters, instead of using the apogee and perigee altitude, you can actually use the period and something called the eccentricity. Now, eccentricity is related to some stuff with math. An eccentricity of 0 means that you have a circular orbit, and 1 means that you're actually going into a parabolic, non-bound one. So basically, you'll have an eccentricity between 0 and 1, but those can be kind of hard to use, even for someone like me who actually knows what those are. First off, I like changing the period to hours, or maybe minutes. And that's something where you can use periodicity, which is a fancy term, but basically it means maybe I could set my satellite to come back at exactly the time I want it to. Something to think about. And then we can adjust the eccentricity here, but what I would actually recommend is going back to your apogee altitude and perigee altitude. What you can do is if you raise your apogee by the exact same amount that you lower your perigee, as long as the two of them add together to be the same number, you'll keep the same period. So for instance, let's go with a period of an hour, or 1.75 hours. Let's adjust this to 2 hours instead. So I'm going to make that exactly 2 hours. I'm going to go back over, and I'm going to go to my apogee altitude and perigee altitude. To do that, I need a circular orbit of 1,680.86. So here's what I can do. If I go up by, I don't know, 300 kilometers, so I'm going to go to 1980.86. To keep the same orbital period, I've now gone up 300 kilometers. I just need to go down 300 kilometers on my perigee altitude. I click apply, and when I go back over, give it a moment to re-update, to period, we can see that I still have a period of 7,200 seconds, which is 2 hours. If instead I go up by 300 kilometers, but only go down by 200 kilometers, so I'm not doing the same thing to both sides, let's see, it's still updating. I'm going to go over to period, and now you'll see that we don't have exactly 2 hours, we have slightly more, 2.01864. In short, this is a brief overview on the connections between apogee and perigee and the effect on your orbital period. Again, if you'd like to know more and in depth, go to General Knowledge on the ISAT website, go over to Orbital Periods and Resonance, and the Orbital Periods video gives you a detailed look through on why this works out mathematically and talks a little bit about the other materials. That reminds me, I should go in and make those orbital resonance videos. I'll add it to my list. Oh, let's go back and see what our next line item is. So we're making a lot of progress. Oh, great. We're done with most of the STK stuff. Now we're at review the penalty paper to avoid needless penalty deductions. We had a lot of penalties last year with a bunch of different teams. Even some of mine ran into some issues with it. So we want to make certain that we avoid that. One of the biggest ones is make certain that you are using the correct format for your team number and your files. It's STLX12 dash and then your 4-digit team number. So most likely the first digit is 0 because we don't really have 1,000 teams, although hashtag life goals. So make certain that you're keeping track of which team you are on, what your officially designated team number is. So you'd go through, and so if you were on team 987, you would have STLX12-0987, and that's how you should put it anytime that you need to do that, if you're typing it into a form or you're making your files that you're going to submit. If you don't, you're throwing away points. Team directors, if you're watching this, or even if this is a competitor watching it, you might recommend this part to your team director. Maybe give a sheet of paper that has exactly the form and the team number to the team so that they can use that for reference when they're filling this out. In short, if you put the wrong thing on there, then StellarXplorers' auto grading system basically chokes on it. StellarXplorers has to have someone go in and manually fix it and set the whole thing up, and it slows everything down. It's also something that should be you should be aware of if you're going into a technology-oriented career or anything like that. There are a lot of times that there are specific forms that you must follow, and you need to get them in exactly that form. So make certain that you're naming things correctly. Skipping the start form. Do not skip the start form. This happens a lot more for locations that have more than one team. Each team must individually begin their start form. That is very, very important. So make certain that you are doing that. Don't go over your 6-hour time limit. Technically, it's only 1% of your scenario score per minute. So if it's like 1 minute late or whatever, but still, my recommendation is make certain that you are ready to close things out and submit things as you're approaching that 6-hour time. Next up, changing fixed variables in STK. This is a big no-no. Don't change things that you're not supposed to. So going back into STK, some of their examples are things like orbit epoch, coordinate types, propagator. So I've got it set to 2-body propagator just for simplicity. But they usually have it as J2 perturbation, but they might have it as something else. The reason I bring that up is when you're working around in here, especially if you're using a mouse with a mouse wheel, if you move the mouse over and scroll the wheel, you don't even have to click on the thing in order to actually change what it says. So for instance, I'm just going to put my mouse over but not click on coordinate type, and then when I roll the mouse wheel, it will change it to equinoctial. I'm not familiar with that one. Anyway, I'm going back to classical. In short, be very careful when you're accessing these, because even if you don't intend to, you might accidentally change one of these settings. And if you change that setting, it causes the grader to break. And once again, StellarXplorers has to go in and take a lot of time to fix the error. So be mindful of where your cursor is and what you're clicking on. What I recommend for my teams is to do, when you open this up and start working it, do File, Save As, and then give it a new name. So for instance, I like to use the actual time. So I might say this is 10:03, or I guess that would be 22:03 hours, however you'd like to keep track of it. But then that way, if you do it with the time code, when you go back to load things, you'll actually find stuff is set up in chronological order. So this is something that isn't necessarily laid out as the recommendations from Stellar, but I do heavily recommend this. When you first get your VDF and you open it up before you change anything else, do Save As and give it a name of Start Here or something like that. Always try and keep your original VDF as you received it from StellarXplorers, and do not save over that. And why do I recommend that? Because here, if you've changed your fixed variables, you might not have realized it. We actually recommend for our teams every 30 minutes to an hour, save wherever they're at, close down the entire program, and reload from the original VDF. So that way, if you did accidentally change a setting, you can catch it before it's too late. Then, when you're actually going to do your final submission and send that file off to StellarXplorers, I recommend you write down all the key things that you want for your solution, close out STK, and once again, load your VDF from the original file sent to you by StellarXplorers, and then that way, you know all of your settings are good because you've gone back to the original file. That's a great way to easily avoid ending up with a penalty from changing fixed variables. And doing it periodically through the competition is a great way to catch in case a small mistake happened. That small mistake could cost you a lot of points. Next up, they say ignoring scenario-specific requirements. The common ones in PR1 and QR1 are sending your orbit too high or too low. So it is common that the launch vehicle might limit our ability to get a satellite high up. So you might be limited to a ceiling of the highest you can put your orbit is maybe 1,200 kilometers. And it is also very common for them to have a floor, is how I describe it on the scenario. They say you can't go below, say, 200 kilometers because your satellite will scrape atmosphere and lose orbit as it deteriorates. Now, that can commonly be anywhere from 200 to 400 kilometers, or maybe even as low as 100. But that's why you have to read the mission briefing in order to know. And keep track of that with your, as I've always recommended, having a constraints board so that you can see exactly what is and is not allowed. Okay, last one is collusion, working with another team or an outside resource. Now, I will say, they said just a minute ago, Like I said, because this is a practice round, team directors and mentors may help students with the scenario, but that is only the team directors and the mentors. Teams are still not allowed to work with one another. Do not talk with any other competitors unless they are on your team. Even if you're at a site that has multiple teams, make certain that you are not sharing any information either directly or indirectly. Stay in different areas. Purposely try and avoid overhearing anything that might be heard. I know sometimes we can be limited on space. At Nationals, at least once, they had a situation where it was cubicles that were dividing teams. You're doing your best to make certain that you're solving it on your own or with the appropriate resources. In this case, while they do say in the practice round for this first one, team directors and mentors can help, that doesn't mean that you can just say that the other student on the other team is suddenly a mentor and you can ask them. No, your goal is to make certain that you're getting a firm understanding of what you're going to do on the actual qualifier round where you won't have any external resources. The other things I'll bring up are I think they've got it on here. Teams may not use programs such as Java, Python, MATLAB, AI resources, pre-built Excel spreadsheets. So that's an important one. So if you've got things that you've put together while working some of my scenarios in ISAT, you are not allowed to bring that in and use it on these rounds. You have to make everything you use in the time of your competition. Now, learning how to build that Excel spreadsheet will help you build it faster during the competition, but you're not allowed to bring it in beforehand. Or other spreadsheet applications, so if you're using Google Sheets or something like that. Files, pre-built checklists, or learning aids, that sort of thing. Those are not allowed in the competition. I've had students ask me about doing programming before. This is not a programming challenge. This is a space mission design challenge. So while programming would be awesome and might make this job much easier, that is not the focus of this. It's kind of like saying if you're going to run a marathon, it would be awesome if you had a bike. But that's not the point of running the marathon. You're supposed to do it with the materials and the limitations that they have listed out. Okay, let's see, team names and files. I think that's the majority of it. Oh, computer usage. As a reminder, you can have two computers that each team are using, but they can only have one copy of STK running at any given time. Now, you can have STK installed on both computers, but you can only have it open on one computer. That's about fair play. That is one of the hard rules and has always been in there. So make certain you are following the rules so we can have high integrity, and a good competition. You are only allowed to use two computers, and when it comes to calculators, you can only use the 5 basic functions, the 4 ones of multiply, divide, subtract, add, and I believe they said memory are the ones that you're allowed to use. I think it's in here somewhere, so feel free to read over that, but I'm not going to read everything just to keep this moving. Don't forget to make certain that you have access to Nova Space, and preferably have looked over the competition training materials, the study guide for PR1, which is right here. PR1 quiz study guide. This tells you the key ideas that are going to be on this academic quiz. It's important to make certain that you can try and do your best on the academic quiz. This is the only practice round that will have one. Okay, I think that's pretty much it. If you haven't, make certain that you read the rule book and you're familiar with how to compete fairly. And then for team directors, we need to move towards compiling your official rosters and get those turned in before QR1. They've got a few more things down here, but I'm going to let you all kind of review that. I think that's all the key ideas that we wanted to cover in this particular prep video. Hopefully that was helpful. Until next time.